Thank you. Have you ever listened to a CD and noticed that something is missing? Or whenever you listen to a vinyl that there's an added warmth to it? My name is McKissack, and today I'm going to talk to you about the differences in analog and digital technology. Because of the advancement in technology, the quality of the music that we listen to has been degraded due to digital processing. After studying this at Texas State, I'm going to tell you the differences in analog and digital technologies and how they sound different. And hopefully after this speech you'll know a little bit about the way CDs are recorded and vinyls are recorded, and maybe you can hear the difference afterwards. First, let's talk about analog production. In my Handbook for Sound Engineers book, it says that sound is recorded through a microphone on a diaphragm, and this is sent electronically to a tape machine. And because sound works on a magnetic level and so does tape, that means that together they work really well. And then the signal from this is sent to a vinyl cutter that cuts the vinyl in the same way that the sound wave is formed, so that it's almost like an exact copy on the vinyl, and that's why it sounds so good. Now let's talk about digital technology. In my class Recording 101, taught by Mr. Mark Erickson, I learned that sound is recorded the same analogously as it is digitally, except instead of going to a tape machine, it goes to a computer, and this sound is converted digitally into like binary numbers like 1, 0, on and off, that sort of like computer term. And basically the way sound is recorded on a computer is you've got two main components, and that's bit rate and sample rate. Bit rate, see, like you've heard of like 8-bit games and stuff like that. Basically 8-bit is saying you've got a binary code, like there's two numbers, so you take the number 2 and you raise it to the 8th power, which equals 256. And whenever you're graphing waveforms on a computer, you've got a y-axis and an x-axis. The y-axis is the bit rate. So say 8-bit, you've got 256 little places where you can take a sample of that waveform or whatever. And so 128 positive and 128 negative. And this comes from the Nyquist theorem, which I learned on electronicdesign.com. Harry Nyquist was a physicist who graduated from Yale, and he basically came up with this theorem that says if you want to sample a sound wave, you've got to take a sample of the peak and the trough of the wave to get like any sort of representation of it. And so that's why, say, the human ear can hear up to 20,000 hertz. That's like really high frequencies. So if you want to take a sample of that, you'd have to make your sample rate 41,000, twice the number as the highest one you want to do. And that's where sample rate comes in. See, and it takes like, if say you had one that was 44.1K, which is 44,100, that means it takes 44,100 samples every second of this waveform. And that's why digital audio files are so huge, is because there's all these little numbers going around to like represent that sound wave. And so now let's talk about MP3s. Basically, an MP3 is a digital file that's just compressed down to the very bare essentials of it, and that's due to a thing called data compression. And they use algorithms and ratios to basically, like an MP3, a .mp3 file, for every 11 bits of information that you have, 10 are thrown out, and then just the one basic bit of information is kept. And that's like, so in an MP3 file, you have basically an 11th of the actual sound that was recorded. And that's why today's music doesn't sound as good as it used to, because there's literally less information involved. But there's also other files like MP4s and .FLAC files, which use algorithms that don't lose any information. And you can have a really small file, but then when you open it up, it's like you have all the information still there, and it's just like a natural recording. So, like I said earlier, due to the advancement in technology, the quality of the music that we listen to is being degraded due to digital processing. We talked about analog production, digital production, and MP3s, and how, from a technical aspect, there's literally less information in a digital recording than there is in an analog recording. Hopefully this speech informed you a little bit about CDs and vinyls and how they sound, and maybe from now on you can hear the differences in CDs and vinyls. Thank you.